Hey guys, welcome to Codeforces Everyday until GM day, what is it? 70, I think? I meant to record yesterday's contest, but I forgot to press record, so no video yesterday, sorry about that. Didn't do too well on the contest. I did okay. I was able to do A and B, in like 45 minutes or so. Could have been faster, but I did lose rating this contest, and I attribute it to the multiple wrong answers I submitted trying to attempt C and D. Because like after the 45 minutes, I have an hour 45 minutes to or an hour 15 minutes to work on C and D, right? C loads up and it's an interactive problem. Like I don't even know what that means. I've never done an interactive problem ever before. So I mean, I tried some solutions, not too sure uh, like what I was doing the entire time. I didn't really know how to debug it either. But so I kind of gave up on C and jumped to D, and then I couldn't really find a solution. Like I thought I had something, but then I realized it didn't work. So yeah, 3 wrong answer submissions. Plus I forgot a test case on a. That's 4 wrong answer submissions minus 200 points right off the bat, like that. So that's probably why I lost rating. I didn't lose too much rating, like under 20 points of rating. So if I didn't submit for CND, I probably would have gained like a little bit of rating. But I'd rather attempt the problems and not try them at all, right? Especially if I'm gonna upsolve them. Either way, now I did like ask a few friends about like interactive problems. It seems like you can kind of just solve them easily. You just have like kind of strange um, input and output. So that's what we're going to work on today. We're going to do this problem C interactive problem, and then we'll look into problem D. Like I thought I had like an idea for how to do C, so that's what we'll be working off of. And then D, it seems like there's not really a trick to it. You kind of just like have to figure it out, and I'm definitely going to need more time to just figure this one out. So yeah, hopefully we're able to do these two today. And if we are, I will be happy about it. I was really hoping I would be able to do at least one of them during the contest, just because I had an hour and 15 minutes. You know, if I'm not doing a question in an hour 15 minutes, what am I even doing? You know what I mean? But all right. Let's just read the question. So you're given an integer n. There is a hidden array. So this array is not given to you. It's length 2n. Each integer from 1 to n appears exactly once in A. The rest of the elements are all 0. You can make the following type of query. Choose 2 integers, I and j. The judge will respond with 1 if ai equals j, and will respond with 0 otherwise. Find any integer k such that ak is equal to 0 and no more than n plus 1 queries. Note that the interactor is adaptive, which means the hidden array A may change depending on your queries, but will not contradict the previous queries. Okay, so what does that mean? That means that, hold on, I'm going to change my desk to standing desk mode so I can lock in a little bit. So that means that we'll have an array. It will have 1 to n through it, or it'll have 1 to n through it, and then like somewhere in the array, it can be in different order or whatever. But then the rest of the array, since it's length 2n, will be filled in with zeros. We want to output okay, let's just keep reading the question. Our goal is to find any integer k such that ak equals 0. So we want to output the index that contains a 0, basically. We know it contains a 0 if so we're allowed to query the array for 2 integers, or indices, I and j, right? If they are both equal to 0, then we know that then we can output or either one, right? If they don't, then it's kind of whatever. It's either like two real or two numbers that are not zero, so like 1, 2, 3, 4, all the way to n, or it might be zero and another number, but we don't know because we don't have that information. So our goal is to query until we are able to find a number that works. Now, my idea during this was that we have an array, right? Let me erase this. Let's just pick a very simple case. Let's do n equals 3. So we have 6. And then our idea was to just query like two, like a sliding window. Not really a sliding window, like a 2-pointer. So we're querying for these two, and then we move each over, query for these two, and then et cetera, right? Move these over, move these over, move these over, until we query the entire array. Now, if they all return a 1, that means like it could be 1, 2, 3, 0, 0, 0, and then each time we move it over, I would query for this, we'll get a 1. Then we can just query like any, let me think. Okay, so first case, this is the test case. So, or this is a, I guess, edge case, but let's just assume this works somewhere. That's 1, 0, 2, 0, and 0, 3. If we query 1, 1, 1, oh, we got a 0. We just output either of these, right? And that's our answer. Now, in this case, what we can do is we can, if all of them fail, it means we have this like zigzag case, right? So, and this is the only other case that we can have where it's zeros mixed into ones by one, and you can do that by just like trying out. You can like notice this by just trying out a few cases, like 1, 2, 3, 0, 0. Oh, you'll have zeros next to each other, right? So this is the only like case where you'd have to do this like unique check. And what you can do is you can just query like the first and the third, or okay, what is going on with my Excalidraw? Just reset the cam. Like I don't know what happens to Excalidraw sometimes, but it just bugs out every once in a while. Like Excalidraw is such a good like tool, but it's just not good enough. Like, okay, there's a hackathon coming up next week, where I'm probably just gonna build my own version of Excalidraw. Not really to win or anything, but like just so I don't have to run into like these errors that happen. Like I've been meaning to have an excuse to build my own online whiteboard. And okay, here's another thing that's annoying. When I'm doing Excalidraw and I'm doing questions with people, I want to be able to share my canvas with people. So my hackathon idea is I make a like collaborative canvas. Yeah, and it'll have like Excalidraw, like all these like tools and stuff like that. I mean, these aren't like specific to Excalidraw or anything, but yeah, and it'd be like people can write on it at the same time, edit the canvas at the same time, stuff like that. And of course, I'll add my own features that I would find useful. that Excalibur doesn't have and stuff like that. But all right, enough about that. We were here to solve problems, not to talk about my life. We can talk about my life, but y'all are here for the problems more than anything. So, okay, we were on the case 0, 1, 0, 2, 0, 3, right? And so we query. Oh, what's going on? Do I have a browser update? No. Yeah, I'm not gonna work with this. Like, if it's deleting like everything I'm writing, it's gonna piss me off. Okay, we're today was already not a good day. You don't want to start this with me. Yeah. Like, this whiteboard has its own issues too. I like Excalibur much better than this one, but like, okay. What is going on? Why are all my whiteboards deleting themselves? My Z key stuck or something? Am I control Zing everything? There's no way you're making me pull up Paint just to... Yeah, Paint doesn't have these issues. This pissed me off. Okay. 0, 1, 0, 2, 0, 3. Right. Sorry. What? Okay, there we go. So we compare each of these, and they all return 1s. So now what we have to do is we compare the first one to like +2 of our current index. So like this, kind of. And if they're all returning 1, like, then you should just be able to first or like check the first one, and if it's both 1s, you print I+1. And or if okay, that's not what I mean by both 1s. What I mean is if they're both, if you compare this and if you compare this and it's a 0, then you can print either, you just print I. If you compare these and it's 1, you print I+1. Right. So that was my idea during the hackathon, but I didn't really know how to. I like implemented something similar, but there was definitely something wrong with it, and I was really struggling to debug with all these question mark exclamation points. I don't even know what like FF flush or like SSTD out flush this stuff even means. So I mean, I've looked into interactive problems a little bit after this, but didn't do too much research on it. But okay, let's just start implementing what I have. Okay, so 1 if same, 0 if not same, and if it's invalid, print -1. So by default, we should set to print to -1. All right. And then we track 2 pointers. Our left pointer should be equal to Well, no, because we're querying. Like, this was the part that confused me a lot during the competition. It's like you're sending I have to think like you're sending a query to the system instead of like I'm iterating through an array, right? I'm sending a query to iterate through the array. I'm not just iterating through array. So I can have it for I in range, and we start from 1, we go to in, and then we query with a print statement. Okay, what is this? Print. And what they want us to do is question mark the two numbers you're querying. So it's like question mark, and then like let me think. 1 to n, that will only iterate through the first n digits. So 1 to 2n. Wait. But then yeah. So it's I and I plus 1. Starts at 1. No, it's I minus 1 and I. And then they want us to flush, right? How do I do this? Flush. Flush equals true. Something like this. And then they will return some sort of output with an exclamation mark. Or no, they will return some outputs. And if that output is wait, I'm confused. Oh, if it's 1, we do if output, then we do it's a 1. If they're the same. If they're okay, then we can break here. We set toPrint equal to I. And we break. And then if we don't find it, we check the first and third index. Else we query for the first and third index. And if it's 1, I just copy all of this. If they're the same, toPrint equals 1, else toPrint is equal to 2. The paint has its own issues too. Can't move multi-mouse button, doesn't have infinite canvas. So if it's 1, they're the same. We print this one. If it's 0, we print index 2. Right, so this is correct. And then we print 2 prints. Or we print 1 with an exclamation mark. Okay. 2 print. And flush. Something like this. Now, okay, I can't test it in this. I have to, in order to test it, I have to run it in my IDE. And then I can't even, like, I don't even really know how to test it. That's the thing. 2, 2. Now, like, what does this, I do 0. And then 1. This is exclamation mark 2. But I don't even know what this means. Like, I have to come up with an array in my mind and then like simulate the queries or something. Like it's really hard to debug in my opinion. Like this might be true. But assuming it's logically sound, let's okay. Let's just test for this case. I hate how the eraser can't erase all these lines. I just new canvas. 0, 1, 0, 2, 0, 3. So the correct answer should just be exclamation mark 1, right? So first we query 0, 1, like this. And we output 0. Then 1, 2, 1, or 2, 3, 3, 4, 5, 6, 7, 8, or I guess it just ends at 5, 6. So it's all 0. Now we check 1, 3. And they're the same, so output's 1. So we just return 1. Then n is 3. 0, 1, 0. 1, 2, 0. 2, 3, 0. 3, 4, 0. 5, 0. And then 1, 3. Should be a 1. So we print out 1. Alright, the thing is, I need to be careful about, it's like I plus 1. To print as I plus 1. Alright, because if it's 0, 0, I'm going to test, like, if our array is like 0, 0, 1, 2, or something. So, n is 2, 0, 1, match. So we printed out 2 for some reason. 1, 2. But we should just print out 1, I guess. But I don't like how it was I minus 1 and I. I don't like how it should be I and I plus 1. But then index out of range. I minus 1, so we start at 2 actually. Then n plus 1. Okay. I think so. I think that's it. Let's try it. Okay. Like, I wish I knew how to debug these kinds of questions. This just makes it so much harder. It makes it so much harder. Because it's like, say your logic is wrong, but you don't know what your output is doing. Like, you start doubting your logic. But I know it's not my logic this time. Query limit exceeded on test 1. So I'm failing on this. Let's say I have... Also, there's a query limit since when? Oh, n plus 1 queries, so we can't do this. This is 2n. Okay, no, we can still do this. We can, I is 1. I minus 1. So we can do 1 to n. We can do 2 times I minus 1. So if it's 1, it's 2 now minus 1. And then this is just 2 times I. This should no longer exceed the query limit. Alright, because it's, say we had this test case, 0, 1, 0, 2. Query 1, 2, 0. Query 2, 3, 0. Query 3, 4, 0. That's 3 queries. N is 2. But we query 1, 2, 3. N plus 1 is 3. So this ain't good. So this should just be it's 2 times I minus 1 is an extra operation for no reason. So what happened here? 3 queries. We're allowed to have 3 queries. One query, 2 query. Uses n plus 2 queries instead of n plus 1. This is a pigeonhole problem. It's like if it's we only care about, well, yeah, since there must be at least one that exists in if everything returns 0, there must be at least one in the other. So we need to do the 1-3 check. Do we need to do the 1-3 check? We need to do the 1-3 check to determine if it's at 2. If so, which check can we get rid of? If we query, okay, let's say we have, if we're querying 1 twice, we're querying 3 twice. So maybe it's one of these that we can get rid of. Like we don't need to. Maybe we just query like 1-3 or something. Let me think. Okay, so we have 2 scenarios. We have, let me grab a new canvas, don't save. We have scenario 1, 0, 0, 1, 2. Scenario 2, 0, 1, 0, 2. If we query starting from, if we don't query 1, 1, we query this, this, like this, and this, and we get zeros. We'll get 0, 0. Then we can do 1-3. And if we get 0, we output 2. And this one we query 1-3, 0. Then if we get a 1, we output 1. does this work? Say I have 1, 2, 0, 0. Query, oh, we found it, output I, or, yeah, I. So we have 1020. Query didn't find it, so we query fail, so we output 2. One, 2, 0, 3. Something like this. Query. Wait, this is in equals 3, so we're allowed 4 queries. This is our 4 query. This doesn't work. We can't just cut one query out because the number of queries we do is one, 2, 3, 4. Number of queries we do is n plus 1. Our n is 2. We did n queries here. But wait, why is this one? What if I do 0, 1, 0, 2, 0, 3, 0, 4, 0, 5? This is 10. Alright, so the number n equals 5. The number of queries we do is 1, 2, 3, 4, 5, 6, 7, 8. 8 queries. So why in this one we do, well, 8 queries are already more than n equals 5. So there's an impossible case. So let's say we assume all the queries. We query 1 and 3. I think 1, 3 is like an important query. Like we always have to query 1, 3. If 1, 3 fails, I don't think it matters how long, we always query 1, 3. There's 2 scenarios. It can either pass. If it passes, then we I. So worst case, let's look at the worst case here. Fails. So this can be there's 0 or x. 0 or x. Right? Now we query 1, 4. If it passes, then we return 1. If it fails, then it's 0 or x again. Now, does knowing 1 help us determine the rest? We know that now that I'm pretty sure skipping this is very good here, because knowing, like, if this is 0, then and these two fail, then this is, wait, let me think. Okay. So if this is 0, this is x. If this is x, this is 0. If either of these are 0, this has to be x. But okay, this infinity shit is kind of confusing me now. Say it's just these 4. We ignore all this stuff over here. If this is x, this is 0. Hmm. Query 8 times. But wait, do we even query 8 times? I'm doing 2 in. So what I'm actually querying is I might 2. So okay, this shit's pissing me off. I miss my whiteboard. So what I'm actually querying is if I have n equals 3. We start here and we query this. And then on I equals 2, I times 2 is 4, then we query this. Then I is 3 times 2 minus, we query this. Don't actually query these. Two minus 2, 4, 3. It uses inquiries. And then we need a query like this. This is n plus 1. If it's 1, then we return a1. Else we return a2. This is n plus 1 queries. Wait, does this even work? Hey, it's 0, 1, 0, 2, 0, 3. These work. But now say it's 0, 1, 2, 0, 3, 0. These do okay, wait, we need to query these as well. It's n plus 2 now. It's like if both of them don't work, no, we don't do this. It's like this. Eventually, like either or has to work. Yeah, this is right. This is n plus 2. So, if I'm able to take out one query from this, we should be golden. Okay. We don't care about queries after. Do we only care about the first 4? It could be 1, 2, 3, 0. No, right. Then it's 4, then it'd be 1, 2, 3, 4, 0, 0. No, we have to query after. So we can't get rid of n. Okay. So we cannot get rid of this. So we're querying like this, right? We cannot get rid of this. We cannot get rid of this check. We cannot get rid of this check. So one of the things we need to get rid of is like one of these in checks. We cannot get rid of this one because this is like containing everything else, right? So it's actually one of these two that we can get rid of. Now, do we need... Could we only check A2 once? We check A1 3 times, and we check A3 and 4 2 times. So say we remove this check. What happens? If it was 1 2 0 0, then we would fail. Because we check this, this would give us 0, this would give us 0, this would give us 0. We can't assume that we don't know for certain which one's 0 from this. Because it could be this one, it could be this one, it could be this one. Wait. Yeah, that's correct. So we cannot remove this one. So we have to remove the first one. Say we remove this one. We check this, this is different. Check this is the same, that's our answer. This is different, we check this is the same. Or we remove the first one. We check this. This is different. So now we know that what do we know? These are different, but they're also different from 1. Both of them are different from 1. So these are, it could be 1, 0, 2, could it? If it's 1, 0, 2, it's different. Then it's different. That could be possible. So it's just A2. There must be a 0 in one of these 3 spots. Wait, okay, now I kind of want to check the other case again. If we check these, if A1 and A2 don't equal 0, that means the zeros are 3 and 4. If A1 is 0 and A2 does not equal 0, that means there is a 0 in A3 or A4, and it will output 1. So this is it. This is why we check. Wait, what do we check? We have to check. Which one do we get rid of? I'm confusing myself. We have to check 3. We have to check 4. Now, do we check current? So, okay. New. Say we know this is 0. We have to check this. We have to check this. If any of these return 1, then we just return this. If both of these return 0, that's worst case, then none of these are 0, and we can just return 1. Or then, yeah, then none of these are 0. Well, if both of these are 0, yeah, then okay. Well, this doesn't actually tell us much. Like the first one's 0. Say, okay, so say it's this one that's 0. What does this tell us? If it's this one that returns 0, none of these will return the same. The 3 or 4 will not return the same. So either 1, 2. We can either compare 1, 2, or 3, 4 here. if we compare, no, we have to compare 3, 4 here, because this tells us if this is 0, then none of these 3 numbers are the same. These are 3 different numbers. If any of them return 1, then there are at least 2 zeros. And we know exactly what those 2 are. So since all 3 of these are 3 different numbers by process of elimination or pigeonhole or whatever, A2 must be 0. So the check we don't have to do is 1 and 2, I think. Now let's check this for bigger numbers. Right, okay, let's just check a few cases. If it's 0, 0, 1, 2, then we check 3, 4, 0. We check 1, 2, or 1, 3, 0, 1, 4, 0. So that means we just return A2. We can try 1, 0, 2, 0. Check 3, 4, 0, 1, 2, or 1, 3, 0, 1, 4, 0. That means we can just return A2. Now, if A2 wasn't in this spot, okay, we can do 1, 2, 0, 0. We check, we found it, we return I. We can do 0, 1, 2, 0. 3, 4, return 0. 1, 2, return 0. 1, 4, and it works. Okay, yeah, I think this is it. Because all of these will check, these will check. And then if we do the from 2 to in, okay, it's like range 1 comma in, and then we do like I times 2 minus 1, I times 1 times 2 is, we start at 2. To n. So we compare I times 2 minus 1 to I times 2. Check if those find it. If those find it, we can break. Else, check 1, 3. If it finds it, break. Or output our answer. If it doesn't, check 1, 4. If none of them find it, output 2. Output, yeah, exclamation mark 2. Okay, yeah. Yeah, this is it. This is it. I think so. So this is from 2 to n. Two times I minus 1. Yes, yes. Okay. Our output is still the same. And we print to I. Right? This seems right. Else we query 1, 3. Output if output print 1. else we query 1, 4. If output to print is 1, else to print is 2. Oh, hold up. Why did we skip a query? Oh yeah, because it goes to, it's n plus 1. Right. Or wait. 1, 2, 0, 1, 3, 0, 1, 4, 0. Should output 2. That's correct. Let's do it again. Print this 3, 3, 4. This is 1, 2, 3, 4 is 0. 5, 6 is 1. My output 6 is correct. Okay. This is an interesting question. It's actually not that bad. This one, I should have been able to get this on the test, bro. It took me so long to like figure out what was going on. It took me an hour, hour and 30 minutes to solve it on my own. But like the concept was of the interactive problem was confusing. Oh my god, I should have been able to get this one. I should have been able to get this one. This one wasn't bad. This one was not bad. Yes, PMO. Alright. Next question. So this one I actually don't really know where to go. Like this one doesn't feel like it has a solution. Or like it definitely does, but it's like there's no trick to finding out the solution. You know, like okay, yeah, what are these tags? Constructive, valgo, and greedy. It's definitely greedy. Like okay, let's read the question first and then I'll explain my thought process. Otter Z decided to make a weapon using ghost fires. He's collected several ghost fires in colors red, green, blue. He will put some of the ghost fires in a row to build a weapon. To make the weapon more possible, Otter Z will use as many ghost fires as possible, but the weapon will be out of control. If there are 2 ghost fires of the same color, adjacent or separated by exactly 2 ghost fires in a row. Okay, the weapon will be out of control if like 2 are next to each other, so like GG, or 2 or separated by exactly 2. So like G, XX, G, the weapon will go out of control. Okay. Yeah. This formal definition over here. That's basically what I just explained. I help them construct the row. There may be several possible rows. So, what I was thinking when doing this problem was there is obviously a most important color, and that most important color is the color that shows up the most. The intuition, I guess, is to zigzag that color. Or not zigzag, but like every other one is that color. So like say G was most, it'd be like GXG, XGX, and then everything else. And so you have an order of most important colors. I thought if it was like RGB, say R is most important, then G, then B. Then you would do RG, RG, RG until you ran out of G's, and then you do like RB or something. But this runs into issues of where if the most important color runs out and you run out of the second most important color. So if you do like RG, 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 so we did 5 of each, and then say you had 2 B's left. Let's say if it was like 552, then you have like BB, and that's no good. But if you like weaved like a B at the start and a B at the end, for example, then you very much could use the entire thing. And our goal is to maximize the string, right? So now I need to come up with a new game plan. RG, RG. Okay, say I had 552. RGB, RGB. Now I have 3, 3. Now I can RG all the way across. This works. So do we try to incorporate the smallest first? Or should we... No, this doesn't work. Because there's gap of 2. So we want to palindrome it, like RGBGR. And then we need something, and then again, maybe? I don't know, or it feels like after a pattern is used, you recompute the most important colors, or after a color is used, you recompute, maybe. That's what I'm thinking, but now I'm thinking it's gonna be slow. Mm. So kind of have RGB. We can have RG, GR. Okay, let's do it like this. RG, RB. G, R, G, B. B, R, B, G. These are our selections. As long as we have the colors for them. If we don't have a color for them, we can eliminate that selection. Now, how do we determine? We have a counter. We have like, let's say we're using this case, R5, G5, B2. So we can use RG, let's say. Now we decrement. This is 4. Now, since it's still the highest, RG again, 3, RG 2. Now they're all 2s. If we RG again, now B is the highest. So then we can choose to, I guess, BR and BG. And this would do 0, 1, 0, 0. Okay, this might work. Like, we just see which pairs we can use. And we calculate like an importance. If it's all 2s, there's alphabetical order. So we have 2, 2, 2. There's R, G, 1, 1. And then B, R, 1, 0. And then GB. This doesn't work. Gap. So we need to track. This doesn't work. There's double gap. So then it's actually like we need to track something else. This is still our first move. Now our next move should have to start with B because it's most important. Now it cannot be R. We track the double gap, and then we eliminate that as an option. So it's G. It has to be G. BG. And then now that they're all equal again, we'll go back to R. We cannot use B because that's what we're tracking. So we use G, RG. And then B. Okay. So we don't actually need to keep track of this, I don't think. We just colors. we have two variables. So, okay, new, don't save. We have RGB counters, right? Step one, max. Or, okay, well, we have two variables. What should I call this one? Two. We call it two. There's nothing so far. And then we can track last. Or like prev. It's empty right now. Step one, remove or disable. Okay, let's remove this as well. They're both empty. Disable prev and two options. Disable prev and two and zero options. Disable prev two count zero options. If impossible, if no options, break. Two. Use max. I'm out of water. Okay. I think this is it. Is this just it? Seems kind of easy. God forbid I run into a case I cannot handle. So if I have 001, disable, disable, we just do B. Call it a day. Alright. Where's my paint? Say I have 111, use R. Our prev is R. It's also 0. So this one's disabled. G, we move 2 is R, now it's G, and we disable G. So then it'll be okay. 0, 3, 0. Disable, disable. G. Prev is G. Disabled. So we just output G. Okay. Two, two, two. R. Prev is R. Disable. This is 1. Disabled. G. 2 is R. Prev is G. This is 1. Disabled. R is still disabled. B. Prev is B. 2 is G. Re-enable. B is 1, disabled. And now we just do RGB again, following the same pattern. So RGB, RGB. And then 273. G, prev is G, disable. Or 6, disabled. B, 2 disabled, prev is B, 2 is G. Or call this prev 2 or something. And then R, 1 disabled, R, B, and G is re-enabled. So then we do G, R, B, there's G, B, wait. Hold up. GBR, right? G. Let's restart this. Use the greatest, G. If it's 6 disabled, our previous is now G. G is still disabled, so we can use anything. We use highest, B. B is, now it's 2 disabled. Our prev 2 is G and B. So now we disable G and B. So now we're forced to use R. R is 1 disabled. R and G and our new prev is R and R2 prev is G. We don't update it immediately. We skip one. We skip a turn. We can have a temporary variable. Actually. So G is not re-enabled. Or G is what's disabled? Right. Okay. Let's redo the process again. 6 disabled. Prev is G. B. 2 disabled. Prev is B, so G is re-enabled. So now we G again. 5 disabled. Prev is G. And our 2 prev is also G. So now it's by count is R. 1 disabled. Prev is R. And R2 is B. So R, B are disabled. So then G is re-enabled. Go to G again. Prev is G. R2 prev is G. G disabled. So RB are re-enabled. We have to do B. Okay, yeah, this I think this works. I just need to make sure I implement it correctly. So step 1. Can R equals true. Okay, I need can R, can G, can B equals true for while can R or can G or can B we do this. We need to track a prev1 and prev2. Okay, let's just prev. Hello, let me make this. Okay. If prev can R can true states dictionary R true G true B true states while states are oh bless you G B if prev 0 equals R. Okay, no. States prev 0 equals false. And states prev 2 equals false. We also need a count of RG and B. So this disables this. Now count equals zeros. If R equals 0, L, or if R equals 0, states R equals false. And we repeat this 3 times. G, B, G, B. And then I feel like I need to do like this, and then I need to disables it. Now can use equals um key for key value in or key dot value. No, it's key value in states dot items if value is true. Okay. And then dot lower to use equals max can use. Okay. To print uh to print dot append to use and RGB. Okay, let's counter equals, let's copy this, RGB B in this counter, and then if counter, wait, I can just do place is counter. And then I don't need a dot lower anymore. I need to do max can use key equals key counter dot get. Is this even right? What this should do is only do the max of the values with the keys and can use. And then counter to use minus equals 1. Print string dot join to print okay. Max iterable argument is empty. So I should print can use B. This is correct. So why didn't okay, we turned everything off. So you're saying we should turn things off after. Well, we should do an initial turn off. which is this. Should do this before anything. Like here. And then move this after. Okay, this turn off should always happen. And then after we do this, we do this, and then we do this turn off again. This should account for zeros. We should delete this. Okay, so mistake here. Our prev is not working. Clearly. We don't update prev. So we should do that. Prev. Zero. Empty. Prev 1. Okay, we have to upgrade. Update prev 2 first. Prev 2 equals prev 1. Prev 1 equals prev 0. And empty. Still doesn't work. Okay. Why? Because false, false. I should do this down here as well, I guess. And then here. Bro, I wish do while loops were a thing. Are they a thing in Python? Well, I guess it wouldn't even matter in this case, I don't think. Although I don't think this even matters. We don't have any prevs initially. Wait a second. Our prev should be the one we just used, which is to use. Prev to use. Right. And then I need to set 1 to true. I should manage states before the 0 check. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Oh man, all this work, and I'm running into the same issue I did during the contest. This 222 case. Two, two, two. R. Prev is R. Don't use R again. G. Prev is G. We can use R again. It's 1, 1, 2. B. Don't use B or R. One, one, one. R. No. It's G. G. Don't use G. It's 1, 0, 1. Then R. One. R. We're only not allowed to use B. Wait. Or just use R. So 0. Don't use B. This is it, and we're not able to put this B down. This happens if they're equal. If they're equal, try to put pointer 1 rather than something new. Max to use. Where am I calculating to use? I have to modify this to be lambda. Counter. Okay. Okay. Equals prev 1. There we go. I don't know if that fixes things, but for all cases, but oh, it worked. It worked. Oh my god, I can't believe it worked. I did it. I did it. It took me less than an hour. It took me 48 minutes. 48 minutes. Why couldn't I do this during the contest? 48 minutes is plenty of time. I had an hour and 15 minutes. Why couldn't I do this during the contest? Like, what's wrong with me, bro? God, if I answered either of these, I'm a little bit pissed off. Because I can do it. Was it time pressure? Am I not practicing time pressure correctly? I guess I did, like, think about the question, like, during the contest a little bit. So, but I have a whole extra, like, 25 minutes to use. I don't know. I passed. I'm happy with it. I got it. I got both of them. It was good. C was C harder than D? I can't even tell you if C was harder than D. I don't think it was. I don't think either of them was that hard, to be honest. These are like 1200 problems. I should have been able to solve these during the contest. I just need more practice, I guess. But yeah, if y'all guys enjoyed this video, be sure to like and subscribe. I will see y'all guys tomorrow. Bye.